Hi, this video will show you how to use operational amplifiers or op-amps to make summing amplifiers where you add inputs together. If you're not familiar with what op-amps are, and you'd like a general overview, there is a video in the description below. But in summary, an op-amp's goal is to make its output the difference between its two inputs. This effect can be used in many ways by adding different components across its terminals, usually resistors. This circuit is what's known as an inverting summing amplifier. There are two DC supplies over here of 2 and 3 volts, both with an in-series resistor of 1K. Connected to the inverting input of the op-amp over here, denoted by the minus sign, there is also a 1K feedback resistor across the top, going across the output and the input, or the inverting input. The circuit is partially based off the inverting op-amp circuit. There is a link in the description to that video if you'd like to learn more. Additionally, I have set a voltmeter across the output so we can see what the circuit itself is outputting. Now this circuit is tricky to get your head around initially, so I'm going to try and explain it by showing it off in action. If I play the simulation, you can see we have a 2 volt supply and a 3 volt supply here, adding together to give 5 volts. So 2 plus 3 gives us 5, but it's an inverting amplifier, so it's actually minus 5. If I now increase the 2 volt supply over here to say 4 volts, so we've now got 4 plus 3, we get 7, or minus 7 again, because it's inverting. So you can sort of see that the relationship between the inputs and outputs is simply these two added together. If I now increase this 3 volt to say 5 volts, and then we got 4 plus 5 gives us 9 volts. Perfect. In this way, whenever an inverting summing amplifier has both input resistors and the feedback resistor up here of the same value, it simply adds the two inputs together, and the output is that, inverted. Now, let's see what happens if I change one of the input resistors. Let's change this first one to say 2K, and see what the output is. You can see we get 7 volts. So what's going on here is we've got 5 volts as normal, plus 4 volts divided by 2, because 2 is double this resistor. So 5 volts plus 4 divided by 2, so plus 2, 5 plus 2 is 7. It's still inverted to minus 7. This may seem confusing initially, so let's look at an equation to prove this. Here we have negative output voltage is equal to RF, or the feedback resistor across the top, multiplied by V1 over R1 plus V2 over R2, where V1 and R1 are the first input supply and resistor in series with each other, and V2 and R2 are the second input supply and resistor in series with each other. Now let's look at an example to make this clearer. Let's say we have a 2K feedback resistor up here, as well as a 2 volt first supply in series with a 2K resistor, and a 6 volt second supply in series with a 1K resistor. First of all, we can cancel the k's because we're multiplying by k then dividing by k in here. This then gives us 2 multiplied by 2 over 2, which is 1, plus 6 over 1, which is 6. So 2 times 1 plus 6, or 2 times 7, which equals 14. Then inverting it to give us voltage output equals minus 14 volts. Let's see if this works in practice. First setting V1 to 2 volts over here, and R1 to 2K, which it already is. Then V2 to 6 volts, and R1 staying at 1K, as well as RF going up to 2K. So we've got a 2 volt supply, a 6 volt supply, with an arrangement of resistors giving us, oh, perfect, minus 14 volts output. It's worth mentioning that if you want a specific quality, for example, you want to work out what this feedback resistor should be in your circuit, then you can go back to the previous equation, and with a bit of rearranging and choosing other values, you can find your answer. Now we're going to move on to the non-inverting summing amplifier, which means the output is the same polarity as the input. The non-inverting variant of the summing amplifier is a bit harder to get your head around, so fair warning. In this circuit we have two DC supplies of 2 volts and 3 volts, the same as our previous example, only this time connected to the non-inverting input of the op-amp. Additionally, instead of one resistor across the top, we now have 2 resistors, one down to ground and one from the output to the inverting input, as well as our voltmeter before to measure our output. This circuit is partly based off of the non-inverting op-amp circuit, link in the description. Whilst the simulation is running, you can see we have 2 plus 3 volts over here, 2 plus 3 gives us 5 volts on the output. Perfect, so working exactly as you would think. If I then change this first supply to say 4 volts, we get 3 plus 4 equals 7, same as before. Going back to 2 volts, if we now change this resistor, which we're going to call RA, to 2K, let's see what happens. So just this resistor here, 2K, we now get 7.5 volts. So that's 1.5 times our initial value. So 2 plus 3 times 1.5 gives 7.5 volts. Okay, interesting. Now let's try 3K over here. So 2 plus 3 is 5 volts. 10. Interesting. So 3K doubles the inputs. This probably seems confusing, so let's look at an equation to help explain this. So Vout is equal to 1 plus resistor A over resistor B, where resistor A was that resistor I mentioned and resistor B was the one next to it down to ground, multiplied by V1 plus V2, so the supply input voltages, divided by 2. Now it's important to note there are more complex versions of this equation that include the input resistors, but they get very complex very quickly, so for this video I'm going to assume they equal, in our case both 1K. To make this clearer, let's do a full example. Let's say we want resistor RA over here to be 3K, as well as RB to be 1K. Then we're going to have V1 as 1 volt and V2 as 5 volts. So that means we get 1 plus 3K by 1K, so the K's cancel and it's just 3. So 1 plus 3 is 4, multiplied by 1 plus 5 over 2, or 6 over 2, or 3. Then 4 times 3 down here gives us 12 volts. Okay, let's test this out in the circuit. So we have 1 volt on the first supply, as well as 5 volts on the second, and resistor RA over here is 3K. Then let's play the simulation. So 1 plus 5 is 6, doubled, gives us 12 volts. Perfect, that's what we expected. Once again, if you want to calculate a value for any specific part of your circuit, say you want to know which resistor A and B to use, then simply use the previous equation with a bit of rearranging to get your answer. The main thing to remember about summing amplifiers is that if all resistors are the same, then the output is just the inputs added together, or inverted if you're using the inverting summing amplifier. Overall, summing amplifiers are extremely useful in electronics and have many applications, such as mixing audio signals together to make one track, amongst other things. This video has been a quick look at summing amplifiers. If you have any more detailed questions, then feel free to ask me in the comments below. Thanks for watching. I upload a new video every Sunday. Be sure to like the video if you liked it, subscribe if you loved it, and have a good day. See ya!